These are ugly. All right, so these can get rough. Let's talk about what's going on here. We have 3 to the 1/3 power times 3 to the 1/4 power, both raised to the 12th. Now, there's lots of rules you could do here, but the first thing you should probably do is to distribute this 12 in exponential space. 3 to the 12 over 3 times 3 to the 12 over 4. 12 over 3 is to the 4th, and 12 over 4 is cubed. And I don't care what the actual number is on too much of these, but this ends up being 3 to the 4 plus 3, which is 3 to the 7th, which is a gigantic number. I'm not even going to write it down. I'm just going to stop right there. What do we have on this one? On this one, we have the 5th root of 64 over the 5th root of 2. And a lot of times it helps to rewrite things in exponential form. Now, since these both have the same exponent, I can look at it as this, 64 over 2 to the 1/5 power. You have a rule that you've memorized that is related to this. I think yours is a over b to the x, is a to the x over b to the x. If you just read that rule from right to left, it's what I did. This becomes 32 to the 1/5 power, and the 5th root of 32 is 2. So that wasn't bad. This one I'm going to do just like I did 22. I am going to view all of this as being raised to the 1/4 power because each particular term is raised to the 1/4 power. Then I'm going to do a little cancellation right there. This becomes 9 times 9 to the 1/4 power, which becomes 81 to the 1/4 power, which is 3. I'm not solving for x, so I don't worry about the whole plus or minus stuff. I'm just saying what the 4th root of 81 is. It's kind of a weird thing in math that we do it that way, but that's how we do it. Only if we need the second answer do we even mention the second answer. 6th root of 256. Why do I think like that's exact, but it's not. Anyways, what you're supposed to do is you're supposed to break this thing into things you can that take the 6th root of. I happen to know that 256 is 64 times 4. Now, why on God's green earth did I write that? Why would I write such a thing? Well, I did it because I happen to know what the 1/6 root or 1/6 power, the 6th root, however you want to think about 64 is. It happens to be 2. That's why I did it. And we'll check it with TI-84 because God forbid I'm wrong. You know, all right? It's 2. This is 2 times 4 to the 1/6, which is better known as the 6th root of 4. So 2 6 roots of 4. And you can't take the 6th root of 4. I mean, you can. It's just going to be a fugly decimal. All right, 5 4th roots of 64 times 2 4th roots of 8. Can't take the 4th root of 8. Can't take the 4th root of 64, but maybe if you put them together, something magical happens. Possibly. 5 times 2 is 10. 64 times 8 had better be 512. Now, if you notice over, well, sorry, the wrong step. Can I take the 4th root of 512? No, but I can get close. I can take the 4th root of, I believe, 256. I believe I can. I'm pretty sure it's 4, or my brain is failing me. And it is. So I evaluate a piece of it. I bring that out front. I evaluated the 4th root of 256, and I'm left with the 4th root of 2. 10 times 4 is 40. 40 4th roots of 2. Fully simplified answer. We got here 3 over the 4th root of 144. Boomer. That's going to be rough. It's going to be rough because a long time ago, some virgin said you can't have a radical in the bottom. That's what's going to make it rough. There's lots of ways to clean these up. Probably the simplest way to do it is just to multiply everything by the 4th root of 144. And that's going to be a good start. That's going to give you 3 4th roots of 144. sitting over 144. Now, all you've done is you've moved your problem from the bottom to the top. You still got a problem. You still got to do something with the fourth root of 144. Twos are great for things like this. 2 to the fourth, last I checked, was 16. And I'm quite confident that 144 is divisible by 16. It should be 9, right? It is. So I think about this top radical as being the 16 times 9. Again, still sitting over 144. Now, the fourth root of 16 happens to be a 2. I'll pull it out and multiply. 6 fourth roots of 9 over 144. And then I'm thinking about the simplification step. 6 and 144, both even, both divisible by 2. Be 3 over 72. Doesn't simplify any farther than that, does it? The 6 under 144. 20 be 120. It does. It's perfect, isn't it? It's 24. So fourth root of 9 sitting over 24. Because 6 times 24 should be 144. Ta-da! All right, moving on. All still pretty close. Dang it, there's 2 more of these. Thought we were almost done with this pile. This one, I love questions like this because kids, man, they look at this and they just don't know what's going on. These are like terms. Your whole goal on this one is to figure out what 3/5 minus a fifth is. And last I checked, it was 2/5. 2/5, cubic root of 5. 28, not like terms, but you can make them like terms. How do you make a 48? 8 times 6? Why 8 times 6? Because I know what the cubic root of 8 is. How do I make a 750? I want something to have a 6 in it. I think 125. I don't know if you caught on what I said. I said I wanted a 6. Because I want things that match when I'm done. All right, so the cubic root of 8 is 2. 2 times 5 is 10. 10 cubic roots of 6 minus the cubic root of 125 is 5. 5 cubic roots of 6. And now we have like terms. 10 minus 5 is 5. 5 cubic roots of 6. That's why I asked you to memorize your squares and your cubes, kids, for this. It makes it easier. Heck, if you know a square, you know a fourth. You just square a square and you get a fourth. Simplify expressions. So yeah, this is closely related. First one are ridiculously easy. 4th root 81 is 3. 4th root x to the 4th is x, 3x. The way this is traditionally taught, and it's probably how I'll teach it when I teach it, is you rewrite each thing as having a power of the root. And then you can just kind of throw them away. You're left with 3x. It's an easy peasy problem. This is something we've done. It just has fractions in it. That's all it is. Nothing more. We'll move the x to the 2/5 down low. We have an x to the first. We're going to put x to an x to the negative 2/5. We have a y up top, and we'll move that y to the 1/3 next. Then we'll just combine exponents, and we'll be done with it. Remember, we add exponents. 1 plus a third is 4/3. Don't write 1 1/3. Don't do it. It's y to the 4/3. 1 take away 2/5 had best be 3/5. Ta-da! This one's not too bad. 3 enters 15 5 times. 3 enters 6 twice. All right, what's going on here? Both these dudes are raised to the negative 3rd power. So what I'm going to do is I'm going to rewrite them in exponential form. 4 over 6, by the way, is 2/3. And I'm going to distribute my negative. That'll become x to the negative 2nd times x to the negative 2nd. Because the 3's cancel. I hope you see that. This becomes x to the negative 4th, written properly, 1 over x to the 4th, because exponents are always supposed to be positive. I think 35. Actually, none of these are hard. Did I pull all the hard ones? This came from an old homework assignment that used to be way harder. Good, they're still there. That's nice to know. 33. the square root of x, 49x to the fifth. So let's do the easy piece. That's 7. And we're going to rewrite x to the fifth as x squared, x. The square root of each of these x squared is x. So 7x, x. And we're left with the root of x on the inside. 7xx would be 7x squared, root x. Fully simplified. 34. You are multiplying radicals that are alike. I would go ahead and do the multiplication first, and then I would simplify because I don't know what the cubic root of 4 is, nor do I know what the cubic root of 12 is, but things happen when you put things together. We end up with a rather large radical that contains 4 times 12, which is 48, an x cubed, and a y to the 7th power. 48 does not have a cubic root. However, it's been done previously on this sheet right here. It's 6 times 8. We're going to rewrite y to the 7th as y cubed, y. So the cubic root of 8 is 2. The cubic root of x cubed is x. The cubic root of each of these y's is y, and y times y is y squared. So I threw away the 8, that. I'm left with the cubic root of 6y on the interior. Ta-da! And the last one I'm going to do, because then I'm going to get something to eat probably. I'll be back here in 12:15. Should give me enough time to eat and chill. Is this one. And this is easy. It's really easy. 3 enters 3 one time. So x to the first is left over. 3 enters 3 three times. Y cubed down low. All right, there you go. I think I've only got about 45 homework problems to go.